Jai Hind everyone. Myself Dr. Pratap Singh, Associate Professor in Department of Mechanical Engineering at AKGEC Engineering College, Ghaziabad, and I'm teaching here the subject Theory of Machine. Today, basically, my fourth video series, and I'll discuss here in the last last lectures. I've discussed the inversion of four-run mechanism and inversion of the single slider current mechanism in details. Now, to continuation of this, we will continue for today lectures. One is we can say that discuss the inversion of double slider crank mechanism, method of to determine the velocity of point on a link, and that the important thing is the Arnold-Kennedy theorem. So, I'll discuss here today in this lecture. I hope you read the previous lecture and understand. If you doubt any query, please contact with us and give the feedback for better. So, come to this the inversion of double slider crank mechanism. So, in the single slider crank mechanism, from name you have find out that in the single slider crank mechanism, you can see that the only one slider, right? But in case of the double slider crank mechanism, we can say that is the two slider is there. Sorry, two slider, or we can say the yes, two slider is there. So, slider pair means sliding pair means that is connected between, it is connected to the sliding motions, right? So, you can see in here in the 4-bar chain, you have the two turning pair, and in this case that the two sliding pairs, and the same kind are arrangement is known as the double slider crank mechanism. So, you can see in this figure that the total 4 linkage, in case that the link number 1, link number 2, link number 3 and link number 4, right. So, you can see here that is the link number 4 and link number 2 is the sliding pair, right, and one is connected to 2 is the sliding pair, and 4 is connected to 1 is the sliding pair. You can see here, I'll write here, basically just erase and then write. So, you can see so sliding pair, 1 4 and 1 2 is the sliding pair, right. One is connected to 2 and one is connected to 4. That is called sliding pair. Two sliding pair and sliding pair. Turning pair is 2 is connected to 3, 2 3, and 3 is connected to 4. So, 3 and 4 is the sliding pair. Sorry, turning pair. So, there are two turning pairs, and these you can see that is the turning pair. Point A and point B is the turning pair, right. This mechanism you can say the double slider mechanism is obtained when the link 1 is fixed and the two adjacent part 2 3 and 3 4 are the turning pair, and other two are 1 2 and 4 in the sliding pair. So, application of this type of we can say use in this the elliptical terminal. So, you can see here in this, you can see in the elliptical terminus, right. So, we can draw the ellipse, or in that case link 1 is the fixed one, the guide slider of the 2 and 4. So, you can see that the 2 and 4 is the slider. You can find out basically with the movement of the slider at any point C on the link 3, expected the midpoint of the AB will be traced an ellipse on a fixed plate. So, the midpoint of the AB will be traced as a circle, right, and let us any instant of the link 3 makes an angle theta. So, what will happen the x axis considering the displacement of the slider from the center of the terminal. So, x we can see here that the x we find out the x equal to BC cos theta and y equal to let at any instant the link 3, you can see the any instant of the link 3, right, make an angle of theta in the x direction. So, that is make an angle in the x direction. So, this angle is theta in the x axis, and considering the displacement of slider from the center of the terminal. So, it moves in terms of like x and y. So, this in the x direction like moves in the y direction and x direction. So, in that case the x will be BC cos theta and y will be the AC sin theta. So, therefore, x you can see that is the x by BC equal to cos theta and y by AC equal to sin theta. So squaring of these two equations and adding, so that you can see here that the x square by BC square plus y square plus AC square equal to sin square theta plus cos square theta. It becomes a 1. So this equation as a represent for the ellipse, right? These equations you can say an ellipse, these equations is so for the ellipse, right? And therefore the path of, you can say, so we can say the path of trace by the C at any point ellipse with the semi major and minor axis, we can say find out, and that being equal to the AC and BC respectively. So in that case, when C is the midpoint of the AB, what will happen? The C is the point C is the midpoint of the AB. What will happen? That equation becomes x square upon BC ka square plus y square upon BC ka square 1. So x square plus y square equal to AC ka square. So which is equation is circle. So it means AC equal to BC, it means radius of the circle is there, right? So ellipse will be converted to the circle. So in that case, you can find out, you can see here that the one is the major axis, one is the minor axis for this. That is the inversion of double sided mechanism for the elliptical terminal. Second one is that is you can say the Scotch Yoke mechanism, you can say, and if the slider block for the first inversion slide is fixed and the second inversion of double sliding crank is obtained. So in that case, when the link 4 is the fixed, so the end B of the crank 3 rotate about A and link 1 reciprocate in the horizontal direction. This type of the application is used the Scotch Yoke mechanism. So you can see here that link 4 is the fixed, right? So it is used for the convert the rotary motion into sliding motion, and as the crank 3 rotates, so the horizontal portion of the link 1 is slide or reciprocate in this fixed link 4. This is the another example of the Oldham coupling. Basically you can say Oldham coupling is used to connecting of the two parallel shafts. Suppose there are two shafts is there and connected to this, then in that case that is used for the Oldham coupling for shaft whose axes are a similar distance apart. So the shafts are coupled in such a way, we can say that if one shaft will rotate, another shaft will also rotate in the same speed. So in that case, the inversion of obtained in the fixing of link 2 and the shaft is connected, have the two flange link 1 and 2 in this figure and rigidly fastened to their end of the forging. So link 1 and 3 of the turning pair, you can say, with the link 2 and the flange have diameter slots cut in the inner faces, and so the figure B, you can see in this figure B. So the intermediate piece link 4, you can say, which is circular disc and have to tongue with the diameter projection. So that is T1 and T2 each face a right angle to each other, and so in this figure of the C. So we can say tongue of the link 4 closely fit in the slots in the two flanges. So it's connected in this place. So you can see here that the particular application of the Oldham coupling connected the two parallel shafts in the rotating in the same direction. So you can use this the Oldham coupling of this inversion of this double slider crank mechanism. Now after that, completing this inversion of mechanism, now come to this the method of determining the velocity of the any point of the link is very important. So in this case, basically you can see there are two methods. One is the instantaneous center method and second is relative velocity method. So property of this instantaneous center I will discuss here for the instantaneous center method, and the next lecture I will discuss the relative velocity method. So what is the property of instantaneous center method? We can say suppose any rigid link rotate instantly relative to another link at the instantaneous center for the configuration mechanism consider. And second thing, we can say if the two rigid link have no linear velocity relative to each other and the instantaneous center, at that point the instantaneous center who rigid link have the same velocity of the with the third link. So in this case, that we can say that the velocity of instantaneous center related to any third rigid link will be same where the instantaneous center is regarded as a point of the first rigid link or the second rigid link. So these are the property of, basically you can say, that the instantaneous center method. So there are three motions of the translation. You can say that one is the motion of translation, one another the motion of rotation, and there is a third, the combination of these. So in figure 1 you can see here, figure 1 you can see that point AB, it translates basically translation motion. So AB it translates to A1 to B1. Second one is rotary motion. So link AB is converted to AB1, and that the combination of these. So you can see that is AB is first of all transfer translation motion. So like you can see that the translation motion is A to A1, and now after that he rotate from A1 to AB1. So there are the combination of these, the combination of motion translation. So a motion of entire translation of the position of point B, you can see in other figure. In this case, you can the motion of entire rotation motion about point AB to position AB dash, and the motion of entire translation motion from AB dash to A1 B1. So that the combination of this, we can say here that is translation. So from A to B, that translation to A1 to B dash, and then again that after translation that convert to the rotary motion A1 to B1, or we can see that A1 to B, then that is rotatory motion A1 to B dash, and then again the translation, the combination of this. So you can see there are a lot of the combination possibility in this case, and then according to that you can use. So the combined motion of translation of rotation of the link from its the entire position of the AB to position A1 B1 may be assumed to be motion of this entire rotation about the center position, right? Entirely rotation about the center point, and this is known as the instantaneous center movement. It means it at the current time, at a particular time, which center about to rotate. Basically, you can say you can find out the center of rotation. Velocity of point of the any link by the instantaneous center method. So we can say that is, you can see here the consider the rigid link AB. You can see here that the one rigid link AB, and let VA and VB is the velocity of the point A with respect to B with the link the direction of shown in figure. So that the point, that one point is link AB, right? Point A and B, and the velocity of point B and velocity of point A in shown in figure, and it is assumed that velocity of point A is known both in the magnitude and the direction, if the velocity of point B is known only for the direction. So in that case, let's find out the magnitude of the velocity of point B. So how to find out? In that case, we are using, basically you can say the instantaneous center method or relative velocity method. So find out I am using here the instantaneous center method. So let's omega be the angular velocity of the link AB in the plane mechanism. So in that case, the instantaneous center I, you can find out the link AB is instant to determine the drawing the perpendicular draw to velocity of the velocity B and velocity A, and intersect where, that we can say that is the instantaneous center. So we can draw here the velocity diagram, draw the perpendicular to this velocity I, you can draw here, and velocity of B is this point to draw the perpendicular to this. So we can find out and cut at point. So these are point I. These I is called the instantaneous center, right? So therefore you can see that the velocity of point B, you can find out the V equal to R into omega, or V equal to R into omega, the omega into IA, or VB equal to omega into IB. So we find out the velocity of B, right? So we can find out the velocity of point B. So VV equal to, the equation 1 is that VV equal to that omega into IA, or the omega equal to VA upon IA, and again VB equal to omega into IB, then omega equal to IB upon omega equal to VB, sorry, omega equal to VB upon omega equal to BV upon IB. So equate both are these are the again the value of omega. Omega equal to VV upon IB and omega equal to VA upon IB. So equivalent कर दिया दोनों both equations. So VV equal to we find out VA upon IB into IB. So you can generate or you can find out the IB position. So instantaneous center method, we can say basically the number of instantaneous center to constant motion you can say are equal possible. The combination of two link. So how to find out the number? How instantaneous center is in each 4-bar mechanism? So or 5-bar mechanism. So the number of parts of the link or the number of instantaneous center in number combination of n link taken the 2 at any time. So mathematically you can find out n equal to n into n minus 1 by 2, where the n is the small n is the number of link. So suppose there are 4 link is there, 1, 2, 3, 4, A, B, C and D, right? So how much I center is there? So in that case there are 4 linkage there, the 4 into 4 minus 1 divided by 2, right? So 4 into 3 divided by 2, that is 2, that is 6. So 6 I center is possible in case of 4-bar chain. So, but if you represent the for 4-bar chain, so 6 center is there, but you can see here that is only for the 4 joints is there. So how can find out? So there are 3 types of this instantaneous centers. One is fixed instantaneous centers, second is permanent instantaneous centers, and fourth one is neither fixed nor permanent instantaneous center. So in that case, those who are fixed, find out the instantaneous centers fixed with the connected to fixed link. So you can see here that the link number 1 is fixed. So instantaneous center between link 1 to 2 and 4 to 1, right? So there is these point A and 2, these are two I41 and I12 is called the instantaneous center. This is called the fixed instantaneous center, right? And second one is neither fixed nor permanent. So these point 4 to 3 and 2 to 3, these are basically you can say that the permanent instantaneous centers, and 2 more is there neither fixed nor permanent. So we extended this link from 4 extended, and link 2 3 is extended, it cut point at point, that is the point 13, and link 3 is extended and link 4 is extended to find out the 2.24. So these are 2 instantaneous centers, and these I13 and I24 is known as neither fixed nor permanent instantaneous center. So how to find out basically these 6? So we can draw the circle. One more thing is there. Suppose what is the location of the instantaneous centers? How to find out the 6 instantaneous center in the 4-bar chain? So which point is the instantaneous center is there? So in that case there are different conditions. So if your 2 links is connected a pinpoint, right? So these instantaneous centers is found out in that joints basically. So you can see here I mention here, you can see I mention here that point 14. This link is joined as the pin joint, right? This link is joined as the pin joint. This link is joined as the pin joint. Here link 2 and 1 is joined as the pin joint. So these point you can see here, if the 2 link is connected to the pin joint, then in that case the center I center will be at the pin joint point, right? Second, if any body rotate in the fixed point, so in that case the center point of trace, we can say point of contact, is called the instantaneous center. If any body fixed and slided to another body, so in that case the instantaneous center lie on the straight line at the infinite. So you can see that one body is a fixed and second is move in this direction. So instantaneous center is lie on infinite. Fourth case is if suppose the curve body is the fixed and slider is slided. So center of curvature is the instantaneous center. If opposite in the direction, right, in the fixed and opposite way move, so in that center of the point is called the instantaneous center. So these are the method of the instantaneous centers, basically how we can find out. So important part of this instantaneous center is that the value equation n equal to 3 into n minus 1 by 2 is basically you can say used through the Arnold-Kennedy theorem. What is the Arnold-Kennedy theorem? It says if the three body moves in a relative to each other, they have three instantaneous centers and it will lie on a straight line. Means if three body moves in relative to each other, they have three instantaneous centers, right? And they have lie in a straight line. You can see here that the three body, right? A, B and C, the three links and connected to each other. Suppose you can find out here n equal to 3. So formula use n minus 1 by 2 capital N equal to. So n equal to n into n minus 1 by 2. So 3 minus 1 divided by 2. This formula 3 into n minus 1 na. So 3, that is called, the value becomes a 3. So number of link is 3 and instantaneous center is 4. So it means all these are in the straight line. So first of all, if you find out the straight line, you can see the basically I'll prove here. You can see in this case for the intensity is the straight line. So that you can see here there are 4 linkages connected, 1 4, 1 center, 1 4, 1 2 and 2 4. So link number 1, link number 2 and link number 4. So there are 3 instantaneous centers. If you can see in the formula, if the 3 body moves in relative to each other, they have 3 instantaneous center in the lie on a straight line. So you can see here in the 4-bar mechanism that if 3 body moves in a relative to each other, they have 3 instantaneous centers, right? So 3 instantaneous center I14, 12 and 24 and it will be lie on a straight line. So it lie on a straight line. You can see here 1 4, 3 4 and 1 3, right? So 1 4, so 1 link 1, link 3 4, link 3, link 4 and link 3. So 3 links is there. 1 2, 2 3 and 1 3. So that link number 1, link number 2, link number 3. So 3 link in the all 3 links lie in a straight line, right? So these we have you can see prove these equations. So first of all, if you draw the number of instantaneous centers, so in that case we can use the n into n minus 1 by 2. So you can put here the value, total 4 were linked here. So you can find out n is number of 4. So in that case that the link is 6. Sorry, link is the 4. So instantaneous center is 6. So for drawing this, we can how to find out the 6th. 4 is that is the 2 is the permanent, 2 is the neither nor permanent and 2 is the fixed. So that you can see one table is there, right? So make a list instantaneous center mechanism. So you can draw the circle and draw the all 4 mechanism, all 4 linkages, and again after that we can connect the center line to listed in this. So 2 4 and 1 3, right? So we can connect it. So these 2 4 basically and 1 4 2 4 and 1 3 is connected. So 2 I centers to find out, and if you draw the I13 and I24, right? So you can see here how to find out I13 is cover the 2 triangle, right? I13 is cover the two triangle. One is triangle 1, 2, 3, triangle 1, 2, 3 and triangle 1, 4, 3, right? So in that case, that is we can fix up extended line in case of the 1, 2, 3, that is 1, 2 and 2 eye centers, I 1, 2 and 2, 3, 1, 2 and 2, 3, and for triangle 1, 4, 3, that is I 3, 4 and 4, 1, I 3, 4 and 4, 1, right? मैं यहाँ पे लिख देता हूँ धीरे से 4, 1, and for in case of link I24, you can see that again I24 is the connected two link two triangle, that is triangle 2, 3, 4 and 4, 1, 2. So in that case 2, 3 and 3, 4, I 2, 3, I 3, 4, and one is from triangle 1, 2, 1, 4. So I 1, 4, I 1, 4 and I 1, 2. So these 8 link basically you can say for the draw of the I 1, 3 you can find out I 1, 2 and 2, 3 and I 3, 4 and 4, 1. So we extended basically the link. So you can see that is I 1, 4 is there, 1, 2 there, I 3, 4 and 2, 3. So if you draw the I 1, 3, so we can extended the line I 1, 2 and 1, 2, 3. So I 1, 2 is there and 2, 3. So these link will be extended, right? And 3, 4 and 4, 1 is the extended. So I 3, 4 and 4, 1 is the extended. This is connected at a point 1. So that is called find out the link of that I 1, 3. If you downward direction is there, so there are no meeting point, right? So these are meeting point upward direction. Second is I 2, 4, I 2, 3 and 3, 4 line will be extended. I 2, 3 and 3, 4 is extended, and second one I 1, 4 and 2, 4 is extended. It connected at point that point. At this point is called the I 2, 4. If you extended left position, so these never will be meet, right? So you can see here that connected these point will be variable. These point will be variable. So you can say that is called the neither fixed nor permanent instantaneous centers. And in that case, there are two fixed instantaneous centers. 1, 4 and 2, 4 is the fixed instantaneous centers, and 3, 4 and 2, 3 is the permanent instantaneous centers, right? Please remember, if you draw, first of all you find out for any type of the mechanism, so you can find out or chain. So if you find out first of all using this formula n equal to n into n minus 1 by 2. After that you can count the number of link in this figure. Suppose in the link suppose the 5 link is there, so in that case that the 5 into 5 minus 1 by 2, that is 5 into 4 divided by 2, 2, 2, 2 कट गया, ये आपका 10 हो गया. टोटल 10 आप I centers होंगे, right? So fixed point, where the fixed point is there, the fixed permanent I center हो गया, fixed I center. Second is where the turning point is there, so pin joint is there, so in that case that will be the permanent I centers. And after that neither fixed nor permanent you can find out. So in that case draw the circle and make the triangle, right? And according to that you can find out, and after that you can see extended the line and find out the neither fixed nor permanent I center. So I hope you have understood the instantaneous centers, how to draw and find out the velocity, and you can measure. According to that you can measure these lines value, and you can find out the magnitude will be, the direction will be given. You can measure this value through measurement and draw this, or you can find out and maintain this, right? So if you any body will given, so for the velocity there are two things is there, one the magnitude and one is the direction. So every time maybe at that point maybe the direction will given or magnitude will be given. Mostly at suppose if you draw the velocity so you can see that the link AB, right? So link AB point A is the magnitude and direction is the given, but point B only the direction will be given. So what will do, we can find out the magnitude of the point B, right? So in that case you can draw the velocity of the perpendicular to this and perpendicular to this. You meet that point, and that point is the instantaneous centers, and then you can find out you can measure the direction, you can measure this distance and find out of the magnitude of the point B. Using this, the angular velocity of the link AB is the constant, that is the omega, so omega is the common. So velocity of point B is already direction is known, so you can find out the magnitude, right? Thank you so much. I hope understand the instantaneous centimeter. In the next lecture, I'll discuss the exercise for the instantaneous center and degree of freedom of this, right? So thank you so much. I hope you understand. If you have any doubt or any query, so please feel free to contact with us. My mail ID the pratap@akgec.ac.in, or my mobile number is 8588870737. Please contact us, right? Thank you so much.